All right, so we're going to be going over the second lesson of chapter 2. And last lesson, we actually talked about the vertex form. In this lesson, we're going to be focusing exclusively on the standard form of a quadratic function. So the essential question today, what key features can you determine about a quadratic function from an equation in standard form? So our learning goal is to be able to write and graph quadratic functions in standard form. So the vocab, all we got to be concerned with as far as vocabulary is the standard form of a quadratic function. What is that? Okay, so let's start with the standard form of a quadratic function. So we actually alluded to this in the previous lesson, but we didn't give it really a name per se. So this is the standard form. So it's y. So it's y equals ax squared plus bx plus c. So that's the standard form. This is actually, the definition of a quadratic function, that the quadratic function has to satisfy this form. So, which is, by definition here, the standard form. So how do we find the vertex if we're given something that looks like this? So I'll give you an example of something that's in standard form. So y equals negative 2x squared plus 5. In this example, so if this is a, then that means a is negative 2. Oops. This is b, and then we'll say that c is this guy. So in this case, all we have is a and c. We don't have a b. So in this example, a is negative 2, b is 0 because there's no x term, and c is 5. Okay, so that's an example of something that's a standard form, but you're missing, the b. The b is 0. So how do we find the vertex using this form? So to find the vertex, we're going to use the following formula. Okay, so the formula for that is x equals negative b over 2a. Okay, so this is going to be the go-to to finding the vertex. So this gives us the x coordinate of the vertex. So basically our h. So when we mean x here, we really mean like h. Okay, so to find this, we plug in whatever b is, and then we plug in whatever a is into the formula. And then to find the y coordinate, we're going to plug in whatever we get for x into here. So we're going to plug in f of negative b over 2a. So basically whatever we get for x, we plug it into the function. All right, so I'll show you how this looks like in the following problem below. So what is the vertex of the function x squared minus 6x plus 10? Okay, so in this case, we're going to be using the formula. So let's first identify our a, b, and c. So we got a here, we got b here, and we got c, c here. So in this case, a is equal to 1. B is equal to negative 6. And C is equal to 10. Okay, so here technically we don't really need the C. All we need is the B and the A. So X is equal to negative B, and B is negative 6, over 2A, and A is 1. So now we got two negatives make a positive. So we got positive 6 divided by 2 times 1 is 2. So we got 6 over 2, which is 3. So x is equal to 3. So this is the x coordinate of the vertex. So for the vertex, we got the x coordinate. So now we need the y coordinate. So to get the y coordinate, we're going to plug this into the function. So f of 3. Which means we're really plugging it in to x here and here. Okay, so we're plugging that in. So now we get f of 3 equals 3 squared. So now we replace the 3 with x minus 6 times, now we replace x with 3 again, plus 10. So 3 squared is 9. 6 times 3 is 8, or negative 6 times 3 is negative 18, plus 10. So we got here f of 3 is 9 minus 18 is negative 9. Negative 9 plus 10 is 1. So remember, f of 3, the f is the same thing as y. So we got our y coordinate. The y coordinate is equal to 1. Okay, so now this is our vertex. Okay, so now we know that our vertex is 3, 1. And that's how you find it if you're given standard form. All right, go ahead and try the following problem. We'll go over it in just a second. All right, so let's go over the problem. So again, this is in standard form. Let's go ahead and find our A, our B, and our C. So here A is equal to 1. There's an invisible 1 there. B is equal to negative 8. And C is equal to 5. All right, so now let's write down the formula. The formula for the vertex, x equals negative b over 2a. So we got negative 8. This is where we plug in b over 2a. So two negatives make a positive, so we get positive 8 over 2, which is 4. So x equals 4. So now we know that the x coordinate of the vertex, so now we need to plug it in to get the y coordinate. So we need f of 4. So this is going to be our y. So y equals f of 4. So we're plugging in the 4 into the x's here and here. So we get 4 squared minus 8 times 4 plus 5. 4 squared is 16. 8 times 4 is 32 plus 5. So we got negative 16. 16 minus 32 is negative 16 plus 5. So you get y equals negative 11. So you plug that in for your y coordinate, and there is your vertex. All right, so let's look at the following problem. So we want to determine the key features if I'm given the standard form of the function. So if I'm given all of this, how do I determine what the features are? All right, so let's start with the vertex. So we kind of already talked about how to find the vertex earlier. So let's practice again. So A, B, C. So x equals negative b over 2a. We got negative, b is negative 4. A is positive 1. So we got 4 over 2, which is 2. So we got x equals 2, so our vertex is 2 for the x coordinate. Now we need to find y by plugging in 2 into the function f. So we're going to plug this in to both x's. So we got 2 squared minus 4 times 2 plus 8. So 2 squared is 4. 4 times 2 is 8. And then we got a plus 8 over here. So 4 minus 8 is negative 4. Negative 4 plus 8 is 4. So our y equals 4. So now we know our vertex. Okay, so we got our vertex. Now we need our axis of symmetry. So remember the axis of symmetry, once we get the vertex, we know the axis of symmetry. So the axis of symmetry is x equals and it's always going to be the h coordinate. So x equals 2. So that's the axis of symmetry. All right, now we need our y-intercept. So to find our y-intercept, we're going to set y to 0. So y-intercept, you set x equal to 0. Okay, so that means that we're going to plug in 0 for x. And we're going to go ahead and plug it in for x is here and here. So we get y equals 0 squared minus 4 times 0 plus 8. So this is just 0, that's 0. 0 plus 8 is 8. So y equals 8. So our y-intercept equals 8. Okay, so those are our 3 features. All right, go ahead and do the same thing for the following problem. Okay, so let's go ahead. We need to find the vertex, we need to find the y-intercept, and we need to find basically what we were finding earlier, which in this case, earlier we found axis of symmetry, vertex, and y-intercept. So let's do our vertex first. So that's A, B, and C. So x equals negative b over 2a. We got negative 6 over 2 times 1. So we get positive 6 over 2, which is 3. So x equals 3. Now we plug it in to get y. So we plug f of 3. So we plug in 3 into x here and here. So we get 3 squared minus 6 times 3 minus 1. So 3 squared is 9. 6 times 3 is 18. And then we got minus 1. So combine these together. This will give you negative 9. Negative 9 minus 1 is negative 10. Okay, so then our vertex is 3 and negative 10. Okay, so we got our vertex. All right, which means that our axis of symmetry is x equal to our x coordinate here. So x equals 3. And then our y-intercept. So for the y-intercept, set x to 0. So that means you're going to replace x with 0 here, here. So that means you're going to get 0 squared minus 6 times 0 minus 1. So you get 0, oh well, these are going to both be 0. 0, 0, 0 minus 1 is negative 1. So y equals negative 1. And that's my y-intercept. All right, so this time we got a word problem. So it says that the graph of the following function, negative 10x squared plus 700x minus 6,000, shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? Okay, so they basically give us a graph and the function, and we just want the maximum profit. So it says maximum profit. So we want to zoom in on that. Remember that since this is a downturn graph, this graph is going down, that means we have a maximum, right? So this is a maximum. So our vertex is our maximum. Vertex is the maximum in this example. So if we find the vertex from this, then we know where the maximum profit is. Okay, so that means that we need to find the vertex of that guy. So here, we got our A, got our B, and we got our c, but we don't really need our c for this example. So remember that the coordinates, the formula is x equals negative b over 2a. So we got negative, and then b is 700 over 2 times a. So we got negative 700 over negative 20. So you need 700, or 20 goes into 700. So we'll do that on the calculator. So 2 goes into 70 35 times. And then there you go. So it's going to be 35. So x is equal to 35. All right. So what does that mean? This means that remember, x is the selling price, right? So this is x, and then this is y. So y is the profit, x is the price. So that means the selling price is $35. This is the selling price. So that means if we sell it for $35, we're going to get our maximum profit. But they're not asking how much we're going to sell it for. They're asking for the profit itself. So we need to find the y coordinate. So to find the y coordinate, remember you're going to plug in 35 into your f. So you're plugging in 35 into your x's basically here and here. So we got negative 10 times 35 squared plus 700 times 35 minus 6,000. Okay, so we go ahead and do the math here. 35 times 35. So this part, if you did this part right here, you're going to get 12,250 plus, and then if you did the other part, 700 times 35, you're going to get 24,500 minus 6,000. Then if you did the math, you're going to get 30,750. All right, I wanted to make a correction real quick. I forgot that this is a negative, so I forgot to bring down the negative. So this is going to be negative to 12,250, so negative right there, which will change our answer. So it'll change it to $6,250. So that's our y. So that's our maximum profit. So this is our actual profit. Which, if you look at the graph, kind of makes sense. It's a little bit above the 6,000, like right there. It's a little bit above the 6,000, so about $6,250. Makes sense. All right, go ahead and try the following problem, and then we'll go over it. All right. So we got another word problem. A water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function negative 16x squared plus 160x plus 50. What was the maximum height of the water balloon after it was thrown? So we want the maximum height again. So when you see maximum or minimum, that means some kind of vertex. So when you see that, when they say max or min, they're looking for a vertex. But they're looking for the maximum height. So they're looking for the y coordinate, right? So we're looking for the y coordinate of the vertex. So in order to do this, we need to break this equation down. So let me rewrite it again. So we need our A, need our B, and that's our C. So x equals negative 160 over 2 times negative 16 we get negative 160 over negative 32, which it goes into it 5 times. So x equals 5. So we got our x coordinate, and this is our x coordinate here. So x is in seconds. But we don't want the time, right? We want the maximum height. So we need to find the y coordinate. So we're going to take this x, this 5 here. So we know our vertex is 5. We need our maximum height. So we're going to plug in 5 into the original function. So we get y equals negative 16 times 5 squared plus 160 times 5 plus 50. So we get, so if we do this out, negative 16 times, so that's negative 16 times 25. 160 times 5, it's going to be 800. And then we got plus 50. Okay, so I'm going to do this all at once on the calculator real quick. We get 450 feet. In this case, our height is in feet. Okay, so that's our, so this right here is our height. So in the vertex, our vertex is 5 and 450, but all we need is the maximum height. So the answer is 450 feet is our maximum height after it was thrown. All right, that's all there is to the lesson, guys. I hope you found this useful, and I will see you in the next video.